figure should have looked like.
I swear I lost weight.
I was just about to say, I thought you said. You beat me too.
Here's what I was stumbling around trying to say last time. So when you put it in symbols, there's no problem. Okay, let us talk about more batch distillation.
Just a quick question.
Yeah.
Is that given n, the number of stages?
Well, let me tell you the problem.
Let
me tell you the problem we were talking about. We were talking about the problem of specifying recovery and purity. Okay. So we said anytime you specify recovery and purity in the initial state, you can go and find the final state at the end of the run. This means that log B over B0 is known. Okay. That's why left-hand side is known. Now, right-hand side depends upon N and R. And right-hand side depends upon N and R in the integral of dxb over xd minus xb. There were two problems. One, you were given R, and your job was to find N. And the other was you're given N, and your job was to find R. And the question we were always asking was, in this case, is R enough, or in this case, is N enough? Well, a compact way of stating what's going on is this baloney here. Now, I'll say something about that, but it's clear?
Yeah.
What did it say? Oh, it's clear, great.
Yeah, I don't know. I can.
Wait, what's the original problem? I don't even know. You erased it.
No, I didn't even put the original problem up here.
Oh.
The original problem we did last time. It's in your
No, I
notes from
wasn't here.
last time. I was just wanted to clarify what limits I was going to take in order to find out whether what the boss tells me will actually work. We have some idea of how to run at constant R. So at constant R, we can solve a bunch of problems. We talked about problems where you were given B and N and R, and you were asked to find what you made. Or we were given XB and N and R, and you were asked to find what you made. Or the problem we're talking about here is you're given the purity and recovery, and you're asked to find out what N given R or what R given N. That's that problem. So constant R stuff, at least in the plain vanilla case, with all of the assumptions we're going to make, is under some control. Now, there's a second way people sometimes do this. second way is to run at constant XD. So here you are, and of course, if you're running at constant XD, that's also XD average. So here you are over here, and you're boiling off stuff, and at some point you're at XB and B, and you're boiling off stuff, and you got a number of stages here, and you're running here, and you're throwing it in here. It's XD all the time in here, it's XD all the time in here. The question is, how do you make it XD all the time in here? And the number of stages is specified, and the way you do that is you increase R. So if you want to run this at constant XD, you've got to increase R at least as long as you can. So that's the plan. Run at constant XD by increasing R. And make the same, up here you were trying to make an XD average and an XD average T over XB0 B0. And we decided how we would do that problem. And I suppose that the number of stages was given, and your job here was probably to find R to make the separation. So your job is to go get R. Now here, it's a little bit different problem. XD is XD average, that's given. So I'm gonna, my specifications are XD is given, it's a constant, and XD T over XB0 B0 is given. I would like to know whether I ought to run this separation to that purity and that recovery at constant R or at constant XD. That's the choice I would like to make. And I think the first thing I would do if I was trying to make this choice is the first thing I would do, solve problem one, this being problem one, for R, solve problem one, find R, and second, find out how much you gotta boil up, second. Okay, how much do I have to boil up to do this? All right, I got to boil up integral from 0 to t of v dt. And that is the integral from 0 to t of r plus 1 d dt. R plus 1 is a constant in this case, so that's r plus 1. Integral from, okay, d dt is minus dB. So I'm going to be integrating from B0 to B of minus dB. So the amount I got to boil up is R plus 1, B0 minus B, B0 minus B, which is R plus 1 times the total amount in the tank up there. That makes a lot of sense. You didn't really have to go through all this to see that. Here you got stuff coming over. This piece of it is filling the tank, this piece is going back. So in order to put a certain D in the tank, you have to have a certain V here. This is what needs to be boiled up. This is returned, that goes to the tank. R is constant, so you get a nice result like this. So I now know how much I had to boil up to do the separation, running at constant R. So let's turn our attention to running at constant XD. XD will be fixed. It'll also be the overhead product composition. And I got to try and decide, in order to compare these, I kind of got to decide how much I have to boil up to do this. Now, we are assuming, when I do this calculation this way, that I might remark that we are assuming N is set and it works. So that N is enough to do the job. And so I'll put beside this N, it's enough to do the job at constant R. Now, it may be enough to do the job at constant XD, it may not, but that remains to be seen. So, we have a favorite equation. What is our favorite equation? It's something like this. Log of P over B0 equals the integral from x B0 to xb of dxb over xd minus xb. Now, when I'm running by increasing r at constant xd, I can integrate this. It's minus the log of xd minus xb over xd minus xb0. So I sit here and I say, is there any information in this equation? And you say, no, there's no new information in this equation. This equation is precisely, you can easily see, this equation is precisely our old favorite xd average, b0 minus b equals xb0 b0 minus xbb. So this equation is not going to help, and so that relieves me from having to do that integration. But it does not relieve me from the responsibility of trying to decide what R corresponds to that XD as XB goes down. So that becomes my only real problem. So what value of R? So I'm going to go to do 2, not find R. I'm going to go do 2. And in order to go do 2, under the conditions that I know XD, and I know the number of stages, I want to find the boil up. Boil up, I'm going to need, boil up is equal to, of course, what we just had before, the integral from B0 to B of minus R plus 1 dB. Now, we integrated this thing in a heartbeat a minute ago because R was constant. R is now not constant, so I've got to be able to do something with this. So one of my jobs is to calculate the boil up. My other job is to find out R versus whatever's convenient. Now, of course, what's convenient is B, but that isn't going to be the most convenient way to work the problem. So I've got a pot sitting here. It's got an XB down here. It's got a B down here. At some point, I'd be wanting to make XD, and I'm always wanting to make XD constant as XB goes down. I got a certain number of stages given. Problem is, what, looking at my sight glass here, what R should I set? And so that's what we'll do. We'll try and calculate that. Once I can find R, and it will be convenient to find R as a function of XB. So we might want to do something about that integral. So let's do something about that integral first. So I'm going to try and find R versus XB in order to do the integral, even though what I'm looking at is B on my sight glass. So, but I know how that goes. It goes like XD B0 minus B equals XB0, B0 minus XBB. So anytime you see a B, you calculate an XB. So that's not a problem. However, when I do this integration, I've got to do a few things. So I notice first that XD is a constant. So I have minus XD dB equals minus XB dB minus B dXB. So I'm going to solve this for B, dB. So dB, so I bring this over to this hand side. So dB times XD minus XB is equal to, the minus signs I'll cancel for now, B dXB. Yeah, the question becomes, do I like this? dB is, this is positive, that's negative. This is positive, that's negative. So I like this. Must have done it right. Okay, so I'm going to replace dB with that. So when I go to find the boil-up is going to be minus the integral from now I'm going to integrate from XB0 to XB of R plus 1 dXB for sure divided by XD minus XB for sure and I got a free B running around that I've not written yet. So I got to stick a B in here. Put a B in here. Okay, what am I going to put into B? Well, I'm going to go to this and observe that a B minus XDB there plus XDB0 there equals X0B0 there minus XBB there. So I guess I'll take this over here and that over there. So it looks like I can put in for B, B0. I see the B0 here and here. It looks like I can put in XD minus XB0 over XD